All right, there is a table on page 222 that talks about the square footage of homes and the asking price of homes in the thousands. Now, the explanatory variable will have to be the square footage because of how they're asking the problem. In part B, they actually ask, draw a scatter diagram. So I put list 1 for my x values, list 2 for my y values, and I did a scatter plot. This is what it looks like. Notice I have asking price versus square footage, Naples, Florida. Here's the asking price. Here's the square footage. I put a scale, and this is what my scatter plot should look like. Part C says determine the linear correlation coefficient between the square footage and the asking price. Now they're asking us to do it the old way, by hand. So again, this is my formula. R equals the sum. Now remember, it was x minus x bar over the standard deviation. That is a z-score for the x times the z-score for the y. Now what I did is I took the data, I did a 2-variable stat of list 1 and list 2, and I got my means, my standard deviation, my means, my standard deviation, and I actually put in my table. List 1 is my x's, list 2 is my y's, list 3 is the z-score. List 4 is the z-score, and list 5 is taking these two and multiplying them together. I get out of my list and I do a sum of list 5 and I divide it by 8 because there was 9 in the sample. And this is the R value that I got. Now, part D said, is there a linear relationship? There is, because I have a positive on my scatter diagram, and I have a 0.916 for my R. So it looks like there is a linear relationship. And it looks like it's a positive association. Now when I look at part E, it says find the least squares regression line, but this time what we're going to do is put it on our calculator. So I find R. This really should be E, and this one is C. So when I go to find R using my calculator, it's the stats, calc. I press 4, which is the line reg, list 1, list 2, vars, y-vars function, y1, enter, and I get this as my lovely equation. And I get my R value to be 0.916, which is right on. Now I have to interpret the slope. What this slope is saying, and I put that answer down here, for every increase of 1 square foot, the asking price goes up 0.06860 thousandths of dollars. Part G says, is it reasonable to interpret the y-intercept? Well, let's think about it. If I have 0 square footage, do I have a house for sale? No. So it does not make sense to interpret the y-intercept in this particular problem. You would never sell a house that has no square footage. Part H says one home that is 1,092 square feet is listed for this amount of money. Is this home's price above or below? So what I did is I took this number here and I stuck it into this equation, and when I got the y hat, it ends up being 158. So yes, this asking price is above what it should be in the predicted. Now, some of the reasons, if you know anything about real estate, location, maybe they have it up to date. I do watch HGTV, so maybe it's all modern and it's all up to date as far as decoration and all those things which could cause them to ask for a higher asking price.